Welcome to another session with me, Varun, on Tech Tablet. In this video, we will be talking about the second part of fourth unit, which is applications and case studies in data science. This is as per the AKNU syllabus, Adikavi Nannaya University, and we would be finishing unit 5, and then we would be going ahead with important questions, and then probably we would be going ahead with more things that are very important for this. So here we have four parts or four topics that we have to close unit 4, of which the first topic is K-means clustering. The second topic is text mining and word cloud. The third topic is recommender system basics. And finally, you have ethical issues in data science. Now, please note that in each of these topics, you have topic 1, 2, and 3, which are practical in nature, and you have topic 4, which is theoretical in nature. Okay. Now let's just talk about each of these and understand a bit. Now, firstly, we have K-means clustering. This is a part of machine learning. Okay. And it's a part of unsupervised machine learning. Okay. It's an unsupervised machine learning algorithm, which means there is no labeled input data which can represent or which can talk about the output. Okay. Now, why do we have the word cluster here? Let us understand the meaning of the word cluster through the image that has been presented here. So now what I'll be doing is I'll be trying to outline the whole image and represent each of them as a cluster. So now let us imagine or suppose that this is your data set. Okay. And in this data set, you have 4 clusters. Okay. So this is your first, this is your second, this is your third, and this is your fourth. They have not been named in order. They've been named randomly. Okay. Now, I think it's very easily understood that each of these is one cluster, right? Like these are a cluster of people. Okay. It's like that. So now, where do we use this or why do we need it is something we'll discuss next. But let us understand what's happening here and why do we need it in the first place. So how does it work or what does it do? So now you understood why we have named it as clustering. Now let us understand why the name K means. And I think you should understand why do we use it in the first place and how does it work, right? So how it works is something, let's see. So here we'll understand the meaning of the word K in specific right now. Okay. So K talks about how many clusters, based on how many clusters and distance should it choose the centroid. Okay. So let us say I have this point here, it's a new data point that is being introduced into the team. Now this data point will firstly check this place. It will then check this place. It will check this place. It will check this place. It will check multiple places and it will finally choose this as the centroid. Why? Because that point is, satisfying the proximity rule when it's being introduced into a new cluster. Okay. So it recalculates different positions and it finally chooses the place which is the centroid. Now, how do we choose the K? Like, obviously, I might put the value of K as 20. I might put the value of K as 5. How would we decide what it is? In order to do that, you have something called as an elbow method. Okay. Now, what is an elbow method? We use a small graph in our language. Okay. Imagine the graph is something like this. In this graph, you have WSS, okay, on one side and K on the other side. Okay. WSS is within sum of squares and K on the other side. Now, when you're working on R to work on K-means, you directly have the function called K-means. So you do not have to go for explicit programming. So you already have something that's visible and that can be something easily doable here. Now, how does K-mean work without a library in the first place? And in order to do that, you have another library called factoextra. Okay. Now, when you're using factoextra, you can use fviz cluster to be able to generate the image. Now, How do we work on this using K-means? I think we were just talking about it. How do we work on K-means using R? This is a small hands-on implementation here. And to keep things easy, we are using the Iris dataset. Okay. Iris is a dataset, and I'm sure most of you who are watching this video have an idea about it. It's one of the most easiest datasets. And the ones that you're seeing here, these are libraries. Okay. And as just discussed, you have Facto Extra, a library within which or because of which you would be able to use k-means or fwiz cluster. Both of these can be used, right? Now, what's happening here? Let's understand. Here, I am trying to take the centers as 3, that is, I'm defining the value of k, and I'm also taking n start is equal to 25, which means I want it to run the algorithm 25 times in different positions for understanding what is the best starting point so I can know that my cluster is stable. And stability is very, very important. Like I would call it a 5-star importance in data science, right? And then as I said, elbow method is used to find out the number of K, right? And here you have WSS is within sum of squares, sum of squares. So using this, you would be able to understand where your new point would be, able to find its new position. Now, here are some real-time applications of k-means. The first one being customer segmentation. Like, let us say you're using Amazon. Okay, in Amazon, you have heavily buying customers, you have medium buying customers, you have small budgeted customers. And then you have customers who buy only during the festivals, customers who buy every day, and customers who hardly buy anything, who just have an account. So all these are segmented within, okay? And for us to do that, which might become very, very difficult, we use k-mean clustering, wherein it goes into the business data, it uncovers the insights, and it gives you the output. It can also be used in medical imaging. For example, you have gone for a chest x-ray, or probably you've gone for an upper body MRI. Now in this, it is very difficult for you to understand directly if it is a tumor, or if it's an ulcer, or if it's a lesion, or if it is absolutely safe and there's no problem at all. Now, how do you understand that? In order to do that, we again use k-means in real life. Then you have document grouping. Document grouping is again, there are many parts of this, like you would be able to understand if, the whole document is an entertainment section, or if it is political section, or if it is international section, sports section. Now, that's one variant. You have another variant wherein you are trying to do sentiment analysis using the document by grouping different documents and things like that. There's a lot of study that goes into understanding textual information, but yeah, let us restrict to basic discussion right now. Then we have anomaly detection. Now let us say you are an Amazon customer who is always doing some fraud attempt just to financially benefit from the platform. In that case, the system would detect your unusual behavior. Like, let us say you are living in a colony with a lot of people. Almost everyone there uses Amazon. But probably you and there's another guy, you are the only two customers who return things very frequently because they are damaged. Now, this is where Amazon, the algorithm would definitely look into it, that when there are 20 people in the same area and all of them are absolutely fine, how is your product only being damaged every damn time? And this is where you would be marked as a potential fraudulent customer, and they would be sidelining you, because of which you might see your account can get blocked, or probably you would not be able to shop on Amazon. Things like these keep happening. Now, the next one is text mining and word cloud. Very, very important topic if you look at it from an industry real-time perspective, because this is how NLP came into existence. Now, what is text mining and what is NLP? NLP is natural language processing. Now, in order to work on NLP, you need to have a good understanding of text mining, and that's exactly what we're talking about right now. Now, what is it? It is the process of extracting high quality information from unstructured text. Please mind you here, the text is unstructured, which means it involves transforming raw data into structured format to be able to identify patterns, trends, insights, analysis, etc. One such example is sentiment analysis. Okay. Now, how do we do this? Like, how does it work? Okay, let me just, put down the example here, like sentiment analysis. Okay. Now, sentiment analysis is one very, very important topic that you might, definitely come across as you keep, pursuing your education. Sentiment analysis is a part of, data science wherein you are given a chunk of information or a chunk of data, and based on the data, you're trying to understand if the sentiment or if the notion of the whole document is positive, negative, happy, sad, threatening, whatever. Okay. Now here you have text pre-processing, which is the first step when you get the raw data. And for that, you have R's TM package. TM stands for text mining. Okay, so you have a text mining package here, which would really help you with things like tokenization, stop word removal, capitalizing, stemming, lemmatizing, etc. Okay, you might not know the meaning of each of the words that I've said, but that's okay. Let's go slow. So this is the first thing that you would be doing. Then the second thing that you would be doing is term frequency. You would measure the occurrences of words in a document. Now let us say there are too many words of one specific type, then it means that this word is being very frequently used. Okay. Now this is where terms like TF, IDF come into play. TF is term frequency. IDF is inverse document frequency. And this is where you identify the words which are most relevant and unique to the corpus. Okay. Why? Because unique words catch the whole text and they extract the information from you. Now, then you have word clouds. Word cloud is a visual representation. So here you can see that this word tan dog has the largest size, okay, of text, okay, which means this is the most occurred word. Okay. Now, why is it like this? Here, it is just a visual representation where larger the word, okay, greater the frequency of the word in your current document. Which means if you have a word that, when I say larger the word, I mean usage. If the usage of one specific word is large, then it is very obvious that the frequency of the word usage is large, which means that word would be represented in a very large size for very simple understanding. Okay, so now you have an understanding of what is text pre-processing, term frequency, and word cloud. Then we have a representation of the code here. And if any of you do not have an idea and you're probably working on this for the first time, then I would recommend all of you to stop, take a break, put a pause, open your laptops, try coding this and get an answer and then go to the next step. Okay, I mean, it's good if you have understood, but it's better and it's excellent if you have understood with practice. I mean, there's nothing that can beat practice. Okay, now this library or this package that is TM, okay, which is for text mining, it uses vcorpus and term document matrix for frequency analysis. Now, what are these? Okay, these are libraries, okay, TM, word cloud. Now, once they are done, you're taking a corpus, okay, now this is the input that you have, text underscore data. Now, you can create a text of your own choice, like create a couple of paragraphs, or you might want to create 20 sentences. I mean, it's completely your choice. And once you've done that, you would now pre-process the whole textual information that you have. Like you would remove punctuation marks, you would remove unnecessary numbers because numbers cannot be deciphered to a meaning. Then you would remove or convert all the elements to lowercase. You would remove stop words, and then probably you would strip white spaces. You don't need space anymore. So all these actions are done, then you would go ahead into the next step where you are trying to document using sort or things like that. Okay, Finally, you're going into word cloud, okay? And in word cloud, you are then generating something like this, which you have seen. Now, this whole image that you're seeing here, okay? Now, this is called a word cloud, right? So I hope you have understood what is corpus and what is TDM. Corpus is basically a collection of document which has text in it, okay? And then you have TDM, which is term document matrix. Now this document, it maps the frequencies across all other documents. Okay, so it tries to map the word frequencies and generate the answer in one place, or the output in one place rather. Now we have one real life application for text mining as well. Actually, we have four real life applications here. The first one is social media analysis. Okay. All these platforms like TikTok, Twitter, Instagram, all of these, you want to gauge real time sentiments to be able to better moderate or better, enhance the performance or experience of the user. Then you have customer reviews. Every time a product is launched on any of the major, e-commerce platform like Myntra, or Amazon or Tata or whatever, any of these, you have reviews, and these reviews are later analyzed to see if the product is genuine or not. Okay, then it can be used in health records or healthcare records also, to choose any patterns of disease if they exist, to probably better cure a patient, things like these. Okay, and finally, news monitoring. PR firms, that is personal relation firms and media intelligence companies, they use a lot of text mining and track brand mentions to understand how a product is performing, to understand how an actor is performing, or probably how a movie is performing across some lakhs and crores of articles that are printed in a daily scale. So this is what we have when we talk of text mining and real-time applications. Then we have the next one, which is recommender system. Now, what is a recommender engine? Let us consider the example of YouTube. You all might have used YouTube for sure. Now, in YouTube, let us say you type the name of one video. Then you would see that in the right hand side, now if this is where the video is playing, okay, and this is where you have the comments, you see that in the right hand side, you have a lot of videos which are recommended based on what you wanted to see uh, in the key search. Now, this is where recommender system comes in. I'll give you another example. You all might have watched Amazon movies or Netflix movies, right? You all might have. Now, let us say your favorite movie is horror or thriller. And when you watch a horror movie, Netflix would automatically suggest you a whole lot of horror movies to see. And how does that happen? It happens because once you've chosen horror as your key interest, the system would start recommending to you based on your interest. It's just like how a human does. Now, let us say your father likes to eat, your father or your mother or your relative, they probably like to eat sweets after dinner. Now, you would by default recommend them to have a sweet of different variety every day, right? But it's still a sweet. That's exactly what the system is trying to do. It, recommends different products to you or different items to you based on filtering, like collaborative filtering, content-based filtering, etc. Now, what is collaborative filtering? Let us just understand this with a small example. Here, your recommendation engine, it suggests items based on user item interaction data. Please mind the words. And when we're talking of content-based filtering, it is based on what you have liked earlier or what you have interacted with. Now, in Instagram, you have content-based filtering, just as an example, based on the reels you watch, based on the type of reels you like, your content would be generated more and more to you, right? So this is recommender system in short. Okay, in order to work on recommender system in our language, you have a library called recommender lab. Okay, and this library would generate recommendation engines for you. Now, these are exactly the same examples I was talking to you. You have Netflix, movies, you have songs. Now, when you choose A, B, C are the songs you like, it would suggest you songs like that. Then you have Amazon, it suggests different products to you. And finally, you have YouTube. This is the first example we discussed, right? So what's happening in all of these places? I mean, if someone asks you what's happening here, I think the only key word that you can say is personalization. Okay. And personalization is probably one of the most important things in the field of IT, because when you're using an application, you want it to work for you and not the general public, right? So this is the work of recommender engine. And when you're working on such big algorithms or on such big data and with so many people, the most important thing that we all have to consider is the ethical issues, because ethical issues keep grounding up every now and then. They keep surfacing every now and then, probably on a day-to-day basis. And what are the major, facets of ethical issues that we're talking about? Trust, fairness, and positive societal impact in every algorithm and insight derived. So basically, everything that you're working on is based on trust, fairness, and positivity, just to keep it short. Okay. While you have these practices, there are certain pillars of data that or of internet that are to be used probably by every person who's using a system in this generation. The first one is data privacy. You need to ensure that the consent or the content used has been given consent with, without which you cannot use or you cannot put it under generic social platforms. For example, I'm a person, I use Instagram, and I do not like anyone else viewing my images. And if that rule is violated, then it is directly a threat to data privacy. Then you have algorithmic bias, which means that your algorithm should not promote only celebrities, or it should not promote only the females of the society. Or if it's doing anything like that, then it is actually called bias. Okay. And whenever we talk of the word bias, then it has an unfair outcome. Okay. And bias is not acceptable. Then we have transparency. Transparency is, whatever is being made, it should be explainable and accountable. Okay. So every stakeholder and user can understand it. And finally, you have misuse of data. This is one thing that should never happen. I mean, it's something that should never ever happen. And what do we mean by misuse of data? Now, let us say I am putting up images of probably a photography wherein I have images of a few males and females. Now, if you are morphing those images just for your satisfaction or for fun, that becomes misuse of data, because you are manipulating the original information and you're posting it. So this is exactly what we are fighting now with Gen AI. And I hope you all know what I'm talking about. We have so many actresses and so many actors who already been targeted to morph the images, which are completely unsafe and not fit for the society. And based on these kind of ethics, we have some real cases that have been happening in the world, which are working and which are still trying to improve the ethics of data. For example, in 2018 at Cambridge Analytica, Facebook user data was harvested without consent. Now, this is a very important word, and this was used to influence elections, which is directly a case of data privacy violation. Then you have Amazon hiring algorithm. You have Amazon's tool, AI tool, which got completely removed after it was found biased against women due to biased data training. So it was selecting only women more and more, and because of this, the whole tool was scrapped off. Then you have GDPR compliance 2018, which is the EU stands for European Union. And here you have the General Data Protection Regulation, which sets a global benchmark. And now anyone who violates this benchmark is basically a crime, okay, is doing or is committing to a crime. So these are the things that you really need to keep in mind when we're talking about the ethics of data science. So with this, we have completed unit 4 of data science of AKNU. In total, In the next video, let us look at the unit 5, okay? And we'll be completing the whole theory probably in next 1 or 2 videos. And then we would be going into important question and answers. I would be providing the list of important questions and answers. And finally, I would also be, taking up, a couple of videos on lab practicals. Okay. So with that, I think your entire syllabus would be complete. And once all these are done, I would also be posting PDFs of these on my YouTube channel. And I think you should be able to access them happily. So yeah, thank you all very much. I hope you've enjoyed the video. If you did, do stay subscribed, stay tuned. This is me, Varun, signing off. Thank you all very much.